So in this lesson, we are going to solve circuit problems using mesh analysis. Now, mesh analysis provides another general procedure in analyzing circuits using mesh currents as current variables. Now, in the previous lesson, we looked at what a loop is, and then we defined a loop as a closed path in a circuit. We said that a loop is a closed path in a circuit. Now, a loop is formed by considering a starting node and then moving through a number of nodes and then returning at the starting node without passing through any other node more than once. Now, on the other hand, a mesh is said to be a loop that does not contain any other loop within it. A mesh is said to be a loop that does not contain any other loop within it. Now, let's consider this circuit to clearly understand the difference between a loop and a mesh. So in this circuit, the closed path formed by A, B, E, F, A is called a loop, and that can also be called a mesh. Now, it can be called a mesh simply because it is a loop that does not contain any other loop within itself. So this loop does not contain any other loop within itself, so it can also be called a mesh. Again, the closed path formed by B, C, D, E, B is also a loop and can as well be called a mesh because it does not contain any other loop within itself. On the other hand, the outer loop, which is the closed path formed by A, B, C, D, E, F, A, even though it is a loop, cannot be called a mesh because inside of the outer loop, we have two meshes, or better still, two loops. We have this to be loop 1 or mesh 1 and then loop 2 or mesh 2. Now, since the outer loop contains at least one loop within it, then it cannot be called a mesh even though it is a loop. So always remember that a mesh is defined as a loop that does not contain any other loop within itself. So considering this circuit, you can say that we have 3 loops and then 2 meshes. So as far as this circuit is concerned, we have this to be mesh 1 and then that to be mesh 2. And the currents I1 and then I2 are called mesh currents. The currents I1 and I2 are called mesh current. Now, in solving circuits using mesh analysis, the first thing we need to do is to assign mesh current to the circuit. Secondly, we apply KVL to each mesh and we use Ohm's law to express the voltages in terms of the mesh currents. And then thirdly, what we do is to solve the resulting equations simultaneously. Now, in this particular lesson, we are going to consider 2 examples. Let's try these examples together. So in the first example, we are going to calculate the mesh currents I1 and I2 in the circuit below. Now, as usual, the first thing we are supposed to do is to assign mesh current, and that has already been done in the question. Now, we have this to be mesh 1 and then mesh 2. So let's move on as we assign branch currents. So we have current I1 flowing through the 2 ohms resistor approaching this node, and then we have current I2 also flowing this way. Now the current flowing through this branch is going to be I1 minus I2. I1 minus I2. So the current flowing through the left branch is I1, current flowing through the right branch is I2, and the current flowing through the middle branch is I1 minus I2. So at this point, let's apply KVL to each mesh. So for mesh 1, KVL states that the sum of the source voltage should be equal to the sum of the voltages dropped across the loop. So considering this mesh, that is mesh 1, we have the source voltage to be 36 volts. So 36 equals Now we have I1 flowing through 2 ohms, so that becomes 2I1 plus current in this branch is I1 minus I2. We are taking the clockwise direction, which is in line with the direction we are taking. So we have plus 12 times I1 minus I2, and then plus we have the same current I1 flowing through the 4 ohms resistor, so that is 4I1. Now let's try to expand this equation. So we have 36 equals 2I1 plus 12I1 minus 12I2 plus 4I1. So we simplify the equation. We have 2I1 and then 12I1 plus 4I1. So 2 plus 4 is 6 plus 12 is 18. So that becomes 18I1 and then minus 12I2, and that is equal to 36. Now we can divide through by 6. 36 divided by 6, we have 6 equals 18 divided by 6 is 3. So we have 3I1 minus 12 divided by 6 is 2. So we have minus 2I2. Now let's call this equation 1. Next, let's move on to mesh 2. We are going to apply KVL to mesh 2. Now notice that the mesh currents are supposed to take the same direction. So you realize that all the 2 mesh currents are taking the clockwise direction. Now generally it is accepted to take the clockwise direction, so each mesh current should take the same direction. So in this case, clockwise. Now once we are taking the clockwise direction for mesh 2, you realize that we have the positive terminal pointing upwards, which means that current is supposed to leave the positive terminal of the voltage source, and that is going to oppose the flow of the mesh current. Hence this voltage source is going to be negative. So we are going to have negative 24, and that will be equal to, moving in the clockwise direction, we have 9I2 plus 3I2, and then since we are moving in the clockwise direction, that is going to oppose the flow of this current. So it becomes negative 12 into bracket I1 minus I2. So we are going to have negative 24 equals 9I2 plus 3I2 minus 12I1 plus 12I2. So negative 24 equals, we have negative 12I1, and then 9 plus 3 is 12. 12 plus 12 is 24. So plus 24I2. Now we can divide through by 12, so that we have negative 2 equals negative I1 plus 2I2, and we call this equation 2. Now for equation 1, we have negative 2I2. Equation 2, we have positive 2I2. So we can add the 2 equations to do away with I2. So let's add. We are going to add equation 1 and equation 2. So for equation 1, we have 6 equals 3I1 minus 2I2, and then plus equation 2, negative 2 equals negative I1 plus 2I2. So let's add the 2 equations. So we have 6 plus negative 2, which is 6 minus 2, that is 4, equals 3 plus minus 1, that is 3 minus 1 is 2, so 2I1, and then negative 2 plus 2, it is negative 2 plus 2, which is 0. So we divide through by 2, and then we have I1 to be equal to 2. So we have I1 to be equal to 2 amperes. Now let's put the value of I1 into any of the two equations. So we can simply put I1 into equation 1. So from equation 1, we have 6 equals now 3 times I1, which is 2, minus 2 I2. So we have 6 minus 3 times 2 is 6. So we transpose 6 to the left hand side, it becomes negative, equals negative 2 I2. 6 minus 6 is 0, equals negative 2 I2. We divide through by negative 2 by negative 2, and then we have I2 to be equal to 0 amperes. So therefore we have I1 to be 2 amperes and then I2 to be 0 amperes. Now let's move on as we solve the second example. So for the second example, we are going to use mesh analysis to find the current I0 in this circuit. So as usual, we have the mesh currents I1, I2, and then I3. So we have 3 meshes in here. And then we are supposed to find the current I0 in the circuit below. Now, first of all, let's try to assign branch current in the circuit. So considering mesh 1, we are going to take the clockwise direction. We have I1 flowing in this direction, in the clockwise direction, flowing through the 4 ohms resistor. And then, mind you, we have current I3 also taking the clockwise direction. Now, I3 opposes the flow of I1. I1 is moving this way. We have I3 also moving that way. So the two currents are opposing each other. Therefore, the current flowing through the 4 ohms resistor is going to be current I1 minus I3. Now, in this branch, we have current I1 flowing in the clockwise direction, and then we have current I2 opposing the flow of I1. So current in this branch is also going to be I1 minus I2. Again, let's move on to mesh 2. We have I2 moving in this direction clockwise, and then we have I3 opposing the flow of I2. So current in this branch is going to be I2 minus I3. And then for mesh 3, we have current I3 moving this way. So we have current I3 moving through the 6 ohms resistor. And mind you, the current moving in this branch is the same current I0. Therefore, we have I3 to be equal to I0. So let's put that somewhere here. We have I3 to be equal to I0. Now let's apply KVL to each of the meshes we have here. So for mesh 1, we have the source voltage, which is 20 volts, and that is equal to the voltages dropped across the loop or the mesh. So we have 4 times I1 minus I3, and then plus 2 into brackets I1 minus I2. So we multiply 4 across, we have 4I1 minus 4I3 plus 2 across 2I1 minus 2I2. So we add 4I1 to 2I1, we have 6I1, and then we have negative 2I2, and then negative 4I3 equals 20. Now we can divide through by 2 so that we have 10 equals 3I1 minus I2 minus 2I3. Let's call this equation 1. Now let's move on to mesh 2. So for mesh 2, we also have this to be the voltage source. This is a current controlled voltage source. we are taking the clockwise direction, so that is going to be positive. So we have 10 I naught equals, in the clockwise direction, you realize that I1 minus I2 is opposing the flow we are taking. We are taking the clockwise direction, we have this in the opposite direction, so it becomes negative 2 into bracket I1 minus I2. This is in line with the direction, so plus 8 into bracket I2 minus I3. So we are going to have 10 I naught equals negative 2 I1 plus 2 I2 plus 8 I2 minus 8 I3. So that will be equal to, we are going to have 10 I naught equals, so negative 2 I1 and then here we have 2 I2 plus 8 I2 minus 8 I3. So that becomes 10 I2 minus 8 I3. So plus 10 I2 minus 8 I3. So we can divide through by 2. We have 5 I naught equals negative I1 plus 5 I2 minus 4 I3. Now notice that I3 is equal to I naught. So let's try to do away with I naught. So we substitute I3 in place of I naught. So that becomes 5 I3 equals negative I1 plus 5 I2 minus 4 I3. Now we can transpose 5 I3 to the right hand side. So that becomes 0 equals negative I1 plus 5 I2, and then negative 4 minus 5 becomes negative 9 I3. So let's call this equation 2. And then for mesh 3, we have voltage source here to be 0. We have no source voltage, so 0 equals, we are going to have 6 I3, and then moving this way, you realize that this is going to oppose the direction we are taking. So that's going to be negative 8 into bracket I2 minus I3, and then still opposing, so minus 4 into bracket I1 minus I3. So we have 0 equals 6 I3 minus 8 I2 plus 8 I3 minus 4 I1 plus 4 I3. So 0 equals negative 4 I1 and then negative 8 I2. Now we have 6 plus 8, which is 14. 14 plus 4 is 18. So plus 18 I3. We divide through by 2. We have negative 2 I1 minus 4 I2 plus 9 I3. Let's call this equation 3. Now we can put this in a matrix form, in a form AX equals B. That is, considering the 3 by 3 matrix, the first row is going to be occupied by the coefficients of I1, I2, and then I3 for equation 1. So that's going to be 3, negative 1, negative 2. And then for equation 2, we have negative 1, 5, negative 9. Equation 3, we have negative 2, negative 4, 9. And then here we are going to have a column matrix of I1, I2, and then I3. And that will be equal to the constants. So we have 10 0, and then 0. Now the question asked us to find the value of I0 in the circuit, and then we are able to establish that I3 is equal to I0. So if we find the value of I3, then basically that's going to be the value for I0. So using Cramer's rule, we know that I3 will be equal to D3 over D. So let's find first of all D and then D3. So for D, we have D to be the determinant of this 3 by 3 matrix, that is 3, -1, -2, -1, 5, -9, -2, -4, 9. So let's try to find the determinant of this 3 by 3 matrix. So we select 3, we cancel out the row and column containing 3, and then we have 9 times 5, which is 45, and then -4 times -9, which is 36. So minus 36. So we have minus, so it is always plus minus plus. So minus -1, and then we multiply this by, we cancel out row and column. We have 9 times -1, that is -9, minus, and then we have -2 times -9, which is plus 18. So plus 18, and then we have plus, so plus -2, and -2 times, we select -2, we cancel out row and column containing -2. We have -4 times -1, that is 4, minus -2 times 5, which is -10. So now let's simplify this. So we are going to have 45 minus 36 to be 9. So 3 times 9 is 27. Again, we have negative, so this becomes positive 1. And then we have -9 minus 18, that is -27. So positive 1 times -27 is -27. Again, we have -2, and then here we have 4 minus -10, which is plus 14. So -2 times 14 is -28. So 27 cancels out 27, because 27 minus 27 is 0. So we are left with -28. Therefore, the determinant of this 3 by 3 matrix is -28. Now let's move on as we find the value of D3. So for D3, we are going to maintain column 1 and column 2, and then substitute column 3 for the constant 10, 0, 0. So for column 1, we have the values 3, -1, -2. So 3, -1, -2. For column 2, we have -1, 5, -4. -1, 5, -4. And then for column 3, we are going to replace that by the constant 10, 0, 0. So we have 10, 0, 0. Let's try to find the determinant of this matrix. So we select 3, we cancel out row and column containing 3. 0 times 5 is 0, minus -4 times 0 is still 0. So minus -1. We cancel out row, column. 0 times -1 is 0, minus -2 times 0 is still 0, plus 10. We cancel out row, column. -4 times -1 is 4, minus -2 times 5 is -10. So -10. Now this goes to 0, this also goes to 0, and we have 10 times 14. So D3 is equal to 140. So therefore we have I3, which is equal to I0, to be equal to D3 over D. And then we have D3 to be 140, and then D to be negative 28. Now 28 goes into itself once, into 140 5 times. Therefore we have I3, which is equal to I0, to be equal to negative 5. So that's it for today's video. Thanks for watching, and see you in my next video. Bye bye.